Let's take a brief look at statistical models used in cyclone forecasting. Statistical models have been used for a long time for weather forecasts, and then the El Nino forecasts also had many statistical forecasting systems, and the hope is always that the dynamical models keep getting better and eventually beat the statistical models, and this doesn't always work. Here we will see that the intensity forecast for dynamical models is still a great challenge, and statistical models seem to beat them systematically at intensity forecasting, although rapid intensification is a new beast that statistical models cannot be expected to capture unless there are enough data that are gathered over the coming years, and then that is built into the statistical system as well. Statistical systems, as you can imagine, use the past information to build relations and then have predictors and predictants. Let's start with the statistical track models. There's one called CLIPER, climatology persistence. This is the only statistical model used in forecasting tropical cyclone track. Since it relies purely on the climatology derived from past storms and on continuing the current tropical cyclone track, CLIPER knows nothing about the current state of the atmosphere. So depending on where the cyclone is, what a cyclone in that location did in the past, it's almost like an analog forecast. It simply replicates the typical track for a cyclone in this location at this time of the year that begins moving in a similar direction as has been observed in the past. If the record is long enough, you think you have a reliable climatology of what happens to that cyclone when it is at that state at that time of the year. For this reason, the CLIPER should not be used as a forecast. However, CLIPER does have one practical application. It is used as a skill baseline to evaluate more complex models. If a track model is not more accurate than CLIPER, climatology persistence, it is deemed to be unusable. After all, if you cannot beat a simple tomorrow's track is the average of other TC tracks that were here today, then obviously your model is not worthy of issuing forecasts. So you take all the past forecasts and look at where the track is today, where the tropical cyclone is today, at what time of the year, and then you say where it is going to go based on past tracks. Your model better be able to beat that basic kind of statistical forecasting, right? Okay, so that doesn't work so well other than serving as a baseline for skill assessment. But statistical intensity models still used at National Hurricane Center can beat dynamic models for intensity forecasts. Here is an example of a rapid intensification that was monumental. So here we are going on October 18th for Wilma, with intensity of 975 hectopascal at 1800 Z and 2015 Z, and near its peak intensity of 882 hectopascal by 945 Z on 10/19. So you can see that GOES images of Hurricane Wilma 2005 show its rapid intensification over 9 hours, from 975 hectopascal to 882 hectopascal. Wilma intensified from a tropical storm to a Category 5 hurricane in 24 hours. Talk about rapid intensification. So statistical models do not have that in the database, so they cannot be expected to capture that kind of intensification. Nonetheless, SHIPS, the Statistical Hurricane Intensity Prediction Scheme, is used in the at the National Hurricane Center. So here it is, Statistical Hurricane Intensity Forecast version 5, SHI-4 5. Uses climatology and persistence, the intensity version of CLIPER that is used as a baseline to measure skill in the intensity forecast models. Okay, so There was the Kleiper track model we looked at, and that served as a baseline for skill measurement, and there is a intensity version of Kleiper as well. Statistical hurricane intensity forecast with decay over land, decay Chi-4, like Chi-4 with climatology and persistence, but only for tropical cyclone over land, a baseline model that provides useful operational intensity guidance. What we don't have here is that insurance, reinsurance industries develop their own statistical models, and they use it for computing damages, premiums, payments, in hurricane-caused damages, and so on and so forth. But they also rely on similar approaches. Statistical hurricane intensity prediction scheme, which is mentioned here. So it's a statistical dynamical model, uses climatology and persistence plus predictors from dynamical models and satellite diagnostics. So it uses humidity, vertical shear, maximum sustained winds, and so on, and builds a relation. And it is updated every year with the previous year's cyclones, so it remains fairly current in terms of the statistical relations, and it's not based on some past data. It's constantly updated, so its skill continues to beat dynamical models. Ships over land, decay ships, it's the same as ships but restricted to tropical cyclones over land. As of 2008, decay ships has been the best intensity forecast model on average, but it cannot track rapid oscillations. Okay, so that's something that statistical models haven't been able to capture yet. With more and more data over time and merging statistical relations with forecasted fields for wind and vorticity and rainfall and so on, maybe they will get better. Ships rapid intensity index, same as for ships but restricted to cases of rapid intensity change, defined as 15 meter per second, 55 kilometers per hour, or 35 mph, or 30 knot maximum wind increase over 24 hours. We defined this several times. It has had mixed success. So there has been attempts to use statistical relations to try to predict rapid intensifications with this statistical model ships, but so far the success is not consistent. Logistic growth equation model, LGEM, similar inputs to ships but more sophisticated statistical approach. In other words, if the models like ships are doing better intensity prediction than dynamical models and can use dynamical forecast information to keep the skill till the dynamical models can consistently beat them, then in this engineering approach it doesn't matter where the forecast skill actually comes from. You are just focused on providing useful, actionable information for managing disasters and so on. So we will leave it there for now and come back to other dynamical methods.